My name is Kel Kozad. I was a mechanical engineering intern at RBC Bearings. My supervisor was Andrew Brown, and I did 2 semesters at this location. During my time at RBC Bearings, I learned multiple different skills that I previously had not known about before. Uh, in the manufacturing stage of bearings, I learned about green turning, heat treatment, post-processing, and assembly. For green turning, these parts had not been heat treated yet, and they were turned with a CNC machine or by hand with a mill or lathe. The heat treatment process would harden the material, and the post-processing was used to dial in the tolerances of the bearings. And then once the bearings were processed, they would be assembled either by hand or by machine. In the machine shop of RBC Bearings, I was also able to learn how to use the manual lathes, mills, and a little bit about the 5-axis CNC machines. I was never able to write any codes for the 5-axis machines, but I was able to observe how they were used and what technicians did with them. In the top right, you can see an image of 3 steel blocks being machined using the mill. And then to the left is a engineering drawing. I was able to learn how to 3D print plastic objects. I learned how to weld, and I learned how to create engineering drawings. In the bottom left, you can see the 3D printer that we used. The bottom middle photo is an image of bearings that I assembled by hand, and the bottom right is an image of a 3D printed part that was used to replace a metal part. During my time at RBC Bearings, I worked on multiple different projects, 2 of them being the Infinity Table and greasing solutions. The Infinity Table is a 60-inch diameter rotating part ejection table. And how this worked is you would place parts on this table, the table would spin, and the guide vanes would push these parts onto a conveyor, and the parts would be picked up by a FANUC robot and placed into the 5-axis machine. These parts would be machined and then taken out by the FANUC robot and be placed into bins. And this was able to hold 200 parts and run continuously, and this removed the need for an operator to be present during the machining process. For the greasing solutions, I created a process to accurately measure grease during hand assembly. This used a grease pump and a Trico grease meter to measure grease as it's pumped out, and then the grease was placed into the bearings. Another project I worked on while I was at RBC Bearings was the UCell, which is a semi-automatic bearing assembly system. I created multiple parts families to run different classes of bearings through this. In the top right photo, you can see a staircase and a grease manifold along with a couple of other parts. The staircase would inject roller bearings into the bearings, and then the bearing was placed onto a conveyor where the grease manifold would inject grease into the bearings. Then a OR was placed on the top of the bearings to cap it off and seal it, and this increased bearing assembly efficiency because it no longer required this hand insertion of grease and hand insertion of the roller bearings. Next, I also worked on a magnetic grease insertion tool. Whenever I got there, these grease fittings were inserted by hand into the bearings and then pressed using a flat cylinder. This was inefficient because the bearing fittings wouldn't always go in straight and they were difficult to keep in place. I fixed this by implementing a magnetic hold to hold these grease fittings while they're being pressed into place. This increased grease fitting insertion by 70% and was very effective. Thank you.